Good morning, viewer. Welcome to our active English version as a breaking. Yeah, a non-toxic coating developed by researchers at University of Toronto Engineering prevents proteins from sticking to surfaces, potentially offering a new tool in the fight against hospital-acquired infection. Right now, the simplest way to keep a surface clean and free of disease-causing microbes is to wash it with disinfectants like bleach, says Professor Kevin Golovin, who heads the durable repellent engineered advanced materials laboratory at University of Toronto Engineering. But of course, it is not great for the humans that work in these environments to be constantly exposed to these toxic products. So, anytime you are using chemicals to kill pathogens, you are increasing the chance of some strain evolving to be immune to them. Goldwyn and his team were experts in designing surface coatings that selectively repel certain substances. And their work has a range of applications from keeping airplane wings ice-free of designing new types of non-stick cookware. Viewers, their latest work published in the Chemical Engineering Journal focuses on preventing infectious bacteria from gaining a foothold. Because many infectious diseases are transmitted by touch, says Goldwyn. And the microbes that carry them typically release a sticky layer of proteins that enable their attachment to a surface. So if you can stop those proteins from sticking, you can stop the disease from spreading. One of the molecules the team has worked with extensively is polymethylsiloxane, that is called the PDMS, a type of silicon polymer that is flexible, transparent, and most importantly, biocompatible. It's already widely used in medical applications from contact lenses to breast implants too. Although PDMS naturally repels bacteria to some degree, and the team believed they could supercharge its ability to do so by changing its molecular structure. One way to use PDMS is to cross-link the polymer chains together into a bulk solid, which is a common material known as silicon rubber, says PhD student Mehdi Sadeghi, lead author of the new paper. But our surface is different. Instead of having interconnected solidified chains, it's instead covered in long chain of PDMS that stick out from the surface like these bristles on a bruise. However, unlike bruise bristles, these PDMS chains are not very steep and they can bend and sway, giving rise to a surface that the team described as liquidy-like, and this makes it difficult for the sticky proteins secreted by bacteria to get a good grip. To test their surface, the team used bovine serum albumin, in the short form BSA, a protein derived from cow's blood, to serve as a proxy for bacterial protein. They placed droplets of BCA dissolved in salt water on their surface as well as surfaces treated with other non-stick coatings. As the droplet evaporates, what you normally see is that the BSA moves in the edges, forming some things that looks like a coffee ring, a dark ring that stays beyond on the surface even after all the water is gone, says Sadeghi. But one of the liquid-like surface covered in PDMS bristles, and we didn't see that. So instead, the ring shrunk along. Further, Sam Goldman says that the team's next steps will include partnering with researchers who study pathogenic bacteria to confirm whether their surface is able to repel real adhesive proteins as well as it does BSA. They are also working with companies who manufacture medical equipment and who might wish to license or commercialize the technology. Behind this exclusive